To most people, this bag of sugar is one of the most innocuous, mundane things in the world. It sits at the back of kitchen cabinets, and no one really gives any thought to how dangerous the material can actually be, and not just to your waistline. Sitting in its bag, or in a canister in the kitchen, and used for the occasional batch of cookies, sugar is, of course, not very dangerous at all. But when poured in large amounts and left around in piles, sugar, or any other combustible particulate material, becomes extraordinarily unsafe. Between 1980 and 2005, combustible dust explosions occurred in 281 facilities, causing more than 119 deaths, 718 injuries, and many millions of dollars in damages. In some cases, entire facilities were leveled. You may wonder how such destruction and devastation can be caused by common dusty materials. After all, the sugar and flour in your kitchen cabinets have never exploded and likely never will. If you have a woodworking shop in your garage, this can be an imminent danger in your home. Sawdust or even metal particulates left lying around carry an explosive risk. Factories, however, operate on a much larger scale than any home projects, making dust explosions more likely and more dangerous if the factory has not put in adequate safety measures to control their occurrence. In order for explosions or fires to occur in either locations, the three conditions on the NFPA fire triangle must be met. There must be fuel, which in the case combustible dust at a concentration that can catch fire, an oxidant, which is generally simply oxygen from the air, and finally, there must be a source of ignition. The ignition of fuel is generally regarded as the initiation step in this type of accident. The following clip shows this initiation step controlled within a laboratory setting at the National Institute for Occupational Safety and Health, or NIOSH for short.
Test number 2, this is Unidyne single-walled carbon nanotubes, A-B classification testing. That was a go.
Notice how easily, even just a small amount of dust at a large enough concentration can ignite.
Test number 5, cheap tube, single-wall carbon nanotubes. movement of the flame. This material actually in the 20-liter chamber did produce a 6 bar overpressure, 6.8 bar overpressure, and a KST or kg or dPdt of 290. So fairly energetic. In this environment, doesn't seem as energetic.
In a factory setting, even a small ignition can cause a large accident, as the propagation step of dust explosions is what makes it particularly devastating. As in the clip before, a relatively small amount of dust ignites, causing the first explosion. One explosion can cause a lot of damage, certainly, but in dust explosions, in factories with very little control of their dust fuel, the one explosion sets off a chain reaction. You may ask why the chain reaction occurs. After all, explosions tend to quickly consume all the fuel in the air, which is why natural gas explosions tend to occur in one large boom. However, in dust explosions, the pressure wave of the explosion and the convection of the air loft more fuel, and the fire from the previous explosion ignites the next. Often, this occurs until there is no longer sufficient fuel left. This is why these explosions tend to level facilities when they occur. So you may ask, how does one prevent these explosions from occurring? This is a very good question. If one takes out a piece of the NFPA triangle, a fire explosion can no longer occur. But which piece can one remove? Most people's instinct is to remove the source of ignition. It seems like a simple fix. Just don't add fire to the fuel, right? Unfortunately, this is very difficult in reality. Certainly, open flames are quite easy to control, but sparks can be caused by any number of things in a factory, or even a home setting. A simple electrical short could cause enough of an ignition source to be a problem. The ignition source cannot be the only thing that is controlled on this triangle because the control is unreliable. What about the oxidizer? Certainly, in most situations, the oxidizer cannot be removed because we need air to breathe. Some plants with highly dangerous material, generally that which could devastate the entire community, do have a system that replaces the air with a different gas if a fire or explosion occurs to suppress it. But this is usually at the cost of the lives of anyone who may still be in the building. So not an optimal choice, and certainly not a choice for prevention. That leaves us with our most controllable option, the fuel. The amount of combustible dust around is controllable because having it in the first place is a choice. People choose to take the risk of processing sugar, flour, lumber, and any other number of things where there is a reward. There is similarly a reward for keeping the processes as clean and dustless as possible. That reward is safety, which protects the company from experiencing loss of workers or equipment. So what is a good system for handling dusty materials safely? Well, thankfully, while you, depending on your position in a company that handles dusty material, may have to think of good designs that limit dust, or the propagation of explosions, or constantly and consistently clean. Your workspace, as your employer requires, there is already an overall standard that provides a framework for maintaining safety in all workplaces that handle any sort of dangerous material that they almost follow by law. This standard is OSHA's Process Safety Management.
The PSM was created by OSHA and finalized in February 24, 1992 in response to the fatal MIC release in Bhopal, India. The purpose of the PSM is to prevent the release of hazardous chemicals and materials and provide a safe working environment for on-site employees. Process safety management has 14 steps. These 14 steps will now be applied to managing and preventing dust explosion hazards. These 14 steps are employee participation, process safety information, process hazard analysis, operating procedures, training programs, contractor safety, pre-startup safety review, mechanical integrity, hot work permits, management of change, incident investigation, emergency planning and response, trade secrets, and compliance audits.
Employee participation. Employees must participate in all the major elements of the PSM that were previously defined by the employer. The first requirement in the PSM standard is employee participation in safety procedures. Here, we see an employee contributing to the safety of a facility that processes a dusty material by cleaning a spill. Process safety information. This section is complied of all relevant information regarding PFDs, process chemistry, and process specifications. In this facility, the safety information is located in a clearly marked cabinet that the employee can easily find. Here, the employee can learn more about the hazards he worked with, including the respiratory and explosive hazards of dusts. Process hazard analysis. This section provides a method that reviews what-if scenarios, checklists, and failures, and is developed by engineers, operators, and other experienced, knowledgeable professionals. Another important part of the PSM is process hazard analysis, which is conducted by industrial hygiene experts. This routine inspection ensures that there are no unsafe conditions in the facility, and if there are, requires that action is taken immediately. Operating procedures. This section reviews startup routines, normal operating procedures, normal and emergency shutdowns, operating limits, and consequences if conditions are not met. Lockout, tagout, and confined space entry are common examples. Employee knowledge and adherence to operating procedures is also a part of the PSM. When the conditions are unusual or unsafe, there should be a lockout, tagout procedure that ensures that conditions remain safe. Here we see an employee notice conditions outside of normal operating conditions where a duct is letting out excess dust and implementing lockout, tagout. Training programs. This section explains the relevant training and renewal training needed for operators to understand the hazards associated with every change they make. Training programs are required in the PSM because they are crucial for educating workers in safe operating procedures and on the hazards that occur in their workplace. At this training session, the workers are learning about the conditions that led to a dust explosion at a sugar factory. Contractor safety. This section highlights the importance of holding contractors to the same safety standards as the company's regular employees. While contractors are technically not a part of the company, part of process safety management is ensuring that their work activities are in the same safety standard as company employees. Here we see a plant worker asking a contractor to uphold the safety standard and notice the lockout tagout placed earlier so that no pre-startup safety review. Engineers and operators go through a checklist to make sure a modification to the process is deemed safe before the modification is used in the process. Pre-startup safety is one of the more crucial parts of the PSM because it ensures that the plant is safe during one of the more dangerous times in plant operations. Often safety of a process is uncertain when a change is made to a process or in a new process, and so it is necessary to do a full safety inspection before startup. In this clip, an industrial hygienist and an engineer are shown during the inspection and finding an issue with a piece of equipment that could cause a dusty environment. Mechanical integrity. All equipment should have scheduled maintenance as well as adequate training for those working on and around the equipment. Especially in dusty processes, mechanical integrity can be imperative to the safety of the plant and is included in the PSM for that reason. A duct that has started to show loss of mechanical integrity, as shown here, can quickly become a problem. If it breaks, it could spill a large amount of dust, causing an environment in which an explosion could occur. This section of ductwork is being recommended for immediate replacement. Hot work permits. All people involved with the process should be aware and trained with the hazards that are associated with welding, cutting, and brazing. Hot work permits include a checklist to remind employees and contractors of hot work hazards. In a facility that has a dusty process, permits should only be given once it is ensured that the area has safe conditions where the introduction of an ignition source will not cause an explosion. Management of change. Management of change ensures that any adjustments in a plant involving equipment and personnel are tested and evaluated before installed or adjusted. Management of change as required by the PSM is also very crucial because changes in a process or misunderstanding of the changes can cause unsafe conditions. The Management of Change document walks the company through changes in its process. Incident investigation. An investigation must be performed on any chemical that may have been spilt or released. This investigation is used to determine what actually went wrong, how to fix the issue, and to ensure it does not happen again. A dust explosion has caused injury to some workers and damaged the facility. For this incident, a detailed report will be filed on what caused the incident and may involve an investigation by the government to ensure the incident does not happen again in the future. Emergency planning and response. There must be a plan that is in place that the company or plant can actively initiate for emergency on or off-site. Good emergency planning and response can reduce the magnitude of accidents that may occur in the future. As incidents occur, the PSM requires an emergency response plan. Since this company has a good one, emergency assistance is immediately offered to the worker injured in the explosion. Compliance audits. The compliance audits allow OSHA to see if a company is actually following their PSM guidelines. These audits should be done at least once every 3 years, and if there is found to be anything wrong, it should be fixed immediately or as soon as possible. Trade secrets. An employer must distribute information regarding their company if it affects the employee's health or impedes them from having a safe working environment. All safety information used to keep employees safe must be provided. Many companies want to withhold information from the contractors to maintain trade secrets. However, the PSM standard requires that contractors are equally well informed so the contractors are not involved in an incident like the previous incident shown due to lack of information. Non-disclosure agreements protect the company's trade secrets.